You're missing out, chica. It's always a week and the day before. Sure. I really don't know. Is it next week? In 2 weeks? Yeah, I don't remember. To be honest with you, I really don't remember. So let's take a look. So it's going to be week 7. So 2 weeks. Because we're in week 6 right now. I mean, week 5. So yeah, you're probably right. Next Wednesday. Next Tuesday or next Wednesday. I'm going to guess it's next Tuesday. When I'll drop the review. All right. So I will say this because someone just said to me that they looked at the video, and today's video was a little confusing. I understand why they thought it was confusing. I absolutely understand it. So hopefully when I go through the notes today, and today's notes was actually long. It was long. Like this, like time-wise. So hopefully I will clarify things that I need to clarify and make those videos shorter in the notes. All right. So first things first. So we're going to have to look at the difference quotient. So the difference quotient let me just start a new page here. All right, so the difference quotient is going to be given to you. You're going to have it, and it states this. So it's not an equation, it's just a fraction. Okay? And if you wonder what the heck a difference quotient is, you'll figure that out when you get to calc. So in calc, the difference quotient is actually the derivative of a function. Okay, what the heck is the derivative of a function for? Well, it's actually another way of finding slope. Except it's not like finding a slope of a line. Okay? It's more of finding a slope, let's say, of a parabola, but it's not looking for, because there's really a lot of different slopes on a parabola, right? Just kind of like this. Just kind of like this right here, right? If I was to look for the slope here, it'd be like this, and it's different depending on the point that I use. Does that make sense? So I'm actually looking for the slope of between these two little points here. So it almost looks like a straight line, right? If I was just to hone in to just those two little points, now it looks like a circle. It looks like a straight line. Does that make sense? If I was to expand that little tiny distance right there, it's going to look straight. Okay? So that's what a difference quotient is actually doing. It's actually looking at a very, very small distance, h, to see what that slope is. So that's what the difference quotient is. It's the difference. Okay? So when it asks you guys to do the difference quotient, it's going to give you a function. So it's going to tell you, hey, find the difference quotient of that. Okay? That's what it's going to tell you. The second part of it, yes. So it's a continuation of Tuesday's notes. So when we look at this and we look at what the difference quotient is there something that looks familiar or looks like the same? Anything look the same? The f of x, right? Because that's what is already given to you. Agreed? Awesome. Now, the h we do nothing about because that's such a small little tiny number. We're not going to do anything with it. We don't care about the h. We don't care how small or how big it is. However, we do need to find that. Is that true? Right? We have f of x. We need f of x plus h. Okay. Here's my question to you then. How do we go about finding f of x plus h? Any ideas? What do you mean by plugging it in?
H plus x plus h into the x's function.
So we're going to put in the f function. Wherever the x is, we're going to replace the x with x plus h. Just like if we were to find f of 2. Right? So, sidebar. Look at this, guys. Check this out. Check this out. Check this out. Here, let me do a sidebar here. So, anybody that got lost with what I just said, do you agree with me? If I said find f of 2, you would say, okay, to find that, anywhere there x is, I'm going to replace it with 2. Does that make sense? Yes? Yes? Everybody got that? Okay. We're doing exactly the same thing. The only difference is that this is x plus h. Does that make sense? So, in other words, I don't really care what's inside the parentheses. If it was f of my shoe, then wherever x is, I would replace it with my shoe. Right? If it was f of my big fat middle finger, then I'm going to replace every single x with my big fat middle finger. Does that make sense? Okay? So, that's why it doesn't matter what it asks for, the process is still exactly the same. So, wherever x is, I'm going to replace it with x plus h. The scary part is this part right here. What do I have to do with that? Write it out twice and double distribute. So you're going to have x squared plus 2xh plus h squared minus 7x minus 7h plus 8. Questions? Where's our questions? We'll talk about that. Any question on how I got this? No? Are we sure? No questions. We're good. All right. Are we sure? So let's look at the difference quotient. Do I have everything I need? Do we have f of x found? We were given that, right? So let's replace it. Except I got to put parentheses around that, right? Because it's minus f of x. Do I have f of x plus h? Okay, let's replace that with this big long thing here. So many things I want to say about that, but not gonna, never mind. Leave it alone. Just leave it alone, man. Do we know where those came from? Yes? So not too bad so far? We're okay? All right. So what I got to do with that negative sign? distribute it. Awesome. So when I distribute it, do you agree that I'm going to get a negative x squared and a plus 7x and a minus 8? And what happens to all three of those? What happened to those three things? They go bye-bye. They go down the toilet. So I'm left with 2xh plus h squared minus 7h all over h. Do we agree? Do we agree? Right? So in other words, if my f of x doesn't cancel out, you did something wrong. So notice that my f of x, that got canceled out because there's a positive x squared. That can cancel out because there's a negative 7x. That got canceled out because there's a positive 8. So if this doesn't cancel out, you did something wrong. Yes, we are. Now, what do we have up top? Starts with a G, ends with a F. A GCF. And what happens to the H? We just found our difference quotient, or our derivative, or our slope of that function.
So most of the time, are we going to be giving the f of x? Or?
You're always going to be given the f of x. So let's go through the process again. Anytime there's a difference quotient, number one, function is given. F of x is always given. So first thing we have to do is find f of x plus h. Once we find that, we're going to plug those two things back into the fraction. The f of x should always cancel out. And the h should always factor out as well and cancel it out as well. Make sense? Okay? So that is where everything is. So function's given, already have it. Find f of x plus h, plug it in. Function should always get canceled out. H should always get canceled out. And then we have our answer. Questions? Are we sure? Huh? You're sure. Okay. All right. There's not much to talk about with relative max and min. So if you guys look at this graph, the arrow on the right says that it's going to go to positive infinity. Is that correct? That means there are numbers that are going to be larger or taller than that peak. Agreed? And the arrow on the left says that it's going to go to negative infinity, which is definitely something that's smaller than the valley. That's why this is talking about relative max and min, right? So relatively speaking, we're going to call this the relative max. And we're going to call this a relative min. So it's all relative. For example, when I played volleyball, and when my teammates, my friends went out, right, relatively speaking, I'm short. Around my volleyball friends, I'm short, right? You know, those guys that are 6'4", 6'7", likes to put their elbow on my shoulder to make sure that I know that I'm short, right? But does it mean that the rest of the bar, there's nobody shorter than me? It doesn't mean that. Right? They're tall. But does it mean that they're the tallest ones around? Not necessarily. But relatively speaking, that's true. That's why I like to hang out with ugly friends. So relatively speaking, I'm pretty good looking, right? So, just joking, guys, I don't. They're like, good idea, let's try this. So it's all relative based on your surroundings, right? So that is why we're just talking about relative max and min. So like I said, there's really not much to talk about because what is the biggest thing about relative max and min? The two questions you're going to be asked is more about when and what. When does a relative max happen? What is it? So if you have an x and y value, like if I can call this a point, you have an x and y value, which one do you think is a when and which one do you think is a what? When does a relative max occur? Is that x value or y value? That's an x. When does the relative max happen is an x value. What is the relative max? Would be your y, hence the height. Does that make sense? I don't think I need to talk about the max is the peak and the valley is the min. I think you guys should know that. Again, but we need to know when, meaning the x value, the time, and what is the height of it, right? That's the y value. So those are only two things that you really need to know. When, x, what, y. That's the important part about min and max. Okay? Now, don't turn the page because I'm also going to add on to this increasing, decreasing, and constant. I'm going to put it right onto this graph as well. And that, except I screwed up the whole equation of it on the second one, when the piecewise. Okay, so if we look at this, you know, we can look at this and say, well, this is decreasing. We can also say that this is decreasing, right? So we got to have some kind of rule in place so that we're all going to be consistent with it. So we're always going to go, just like we would write our domains, just like we would write intervals, we always write from least to greatest, or from left to right, from negative infinity towards positive infinity, right? And because I'm saying from left to right, that means I'm talking about the x values, okay? So when I write these, it's about the x values. I'm going from negative infinity to positive infinity. So that means I'm always going from left to right. So from left to right, right here is increasing. Right here is decreasing. Right here is increasing. Everybody agree? So if it goes up, it's increasing. If it goes down, it's decreasing, right? We got to be consistent, so we're all going to go from left to right. So we're all saying the same thing. Okay? Now the question is, what happens at the peak and at the valley? Is it increasing? Is it decreasing? Or is it constant? Okay, so constant means this. That's why she says she likes my graph on my pre-recorded video, is because I actually have a constant in there. Constant just means a flat line. Okay? So on the peaks and valleys, it's neither increasing, nor decreasing, nor constant. It's a transition point, just like in sports, right? You're either on offense or you're on defense. You're not playing both at the same time. Can you imagine in football someone's trying to play offense and defense at the same time? It just doesn't work. Coach is like, get out. I don't know what you're doing, just get out, right? Same thing with basketball. Can you imagine? Dribble. And then dribble the same ball and guard the same ball. Dribble. Just get out. You're fired. Come back next year. Actually, don't ever come back, please, right? You're either on offense or you're on defense. But in between is a transition from offense to defense or defense to offense. Same thing here. Increasing, transition, decreasing. Transition, increasing. So because those peaks and valleys don't mean anything or don't have anything going on, that's the reason why these are always going to be open intervals. Meaning we're going to be using parentheses, no square brackets. Does that make sense? Okay? Now, if I was to write intervals, or if I was to write something about increasing, then I know going from here to here is increasing, and from here to here is increasing. Agreed? So if I was to write this, it's going to be 2.
So have we written a domain?
Right? We said going from left to right, so it's the x values. So I'm only looking at x values. X values going from negative infinity to negative 3. And then at 3, it starts increasing to positive infinity. Agreed? And how about decreasing? Again, open intervals.
So I'm confused. Why do we start at -3 if it's going down this way? Do you understand that? Because it's at positive right now. Oh, just kidding. No.
Again, I'm going from left to right.
Yeah.
So I'm looking at the x values, nothing about the y values. Does that make sense? Because you were looking at the y value.
No, I just forgot that the bottom x-axis is negative, but the top y-axis is positive.
Oh, okay? Questions? Ask the questions you need to ask. Well, good? People at home are good? Are really sure? All right. Try and pause a little longer. Hold a little longer. Are we sure?
Yeah, you didn't graph very well.
What do you mean?
That left circle is not on 3.
I'm worried about the x value, not the y value.
The x-axis, it's on the negative 3.
You're still looking at the y value. The x value is -3 to +3. So I'm looking at the x value. So here's the thing, guys. let me put it this way. So someone did ask me in the last class, is there any point in time where they're going to be looking for the y values and not the x values? And I said this. I said, okay, so let's, for example, take so here's the thing. If you look at these two, right, so that means I'm looking at just y values. Everybody see that? If I only look at y values, don't I see increasing and decreasing and increasing all in here? I can't block off just increasing. Does everybody see that? But if I close it the other way, the x values, I can block off only seeing the decreasing. Or only seeing the increasing. Does that make sense? So that's why I'm looking at just the x values and not the y values. So if I do this and this, you'll see that it's going from -3 to +3. Cool? Any questions there? Any other questions there? Okay, let's see if this explanation will help better than the video. Because the video was good but not great. Well, you know what? How about if I put it this way? I believe that what I'm about to explain to you is a better way of getting the graph where the video was talking about going the other way. So, all right, so what is a piecewise function? A piecewise function is like a Frankenstein of functions, right? So when they built Frankenstein, they took the ear of one person, right? Ear of the other person, right? Face of another person, head of another person, right? Like they took a bunch of different people and then took pieces and put it together as one person, right? Like Frankenstein doesn't have 5 ears. Does that make sense? So Frankenstein still had to like kind of represent a person. Same thing here. Whatever I decide to do, whatever function I decide to cut up and put together, it still has to represent a function. Meaning it still has to pass the vertical line test. Make sense? Okay? So it still has to. So the question is, how do I go about doing that? So again, this is piecewise. That means I could take 2 functions, cut it, and say, here it is. Put it together. But it has to pass the vertical line test. Right? And the other meaning of function is what? Each x value corresponds to one and only one y value. Okay? All right. So now I want to do one that is more difficult for a reason. So here we go. Oh, I know this is going to happen. There it is. So in this case, I took 3 functions. I cut it into pieces, and now I'm going to glue them together. Okay? So again, 3 different functions. Do I agree with that? Are we okay? Okay. Do you guys agree that this one right here is going to be y equals 2x minus 1? Agreed? This one here is going to be y equals negative x. And this one right here is going to be y equals x squared minus 1. Everybody agree with that? Are we okay with this so far? Because the f of x out here just means each of them is f of x, right? It's just calling it the same function called f of x. What kind of graph is this? Is it, well, horizontal is linear. Vertical is linear. Is it horizontal or vertical? No. What kind of line is it then? Diagonal. And why is it diagonal? Why do we know it's diagonal? Okay. What is the other explanation I said? What's the degree of x? That means it crosses the x-axis once. What's the degree of y? That means it's going to cross the y-axis once. Hence the diagonal line. The diagonal line tends to cross the x-axis once, the y-axis once, right? Okay. Now, a vertical line. Most of them cross what axis? X-axis, and it's only once, right? That's why that equation is x to the first power, and no y value in there. Vertical crosses the y-axis, hence it's y to the first degree, and no x in that equation. How about this equation? What is that? Also diagonal, because the x is to the first degree and the y is to the first degree. That means it crosses the x-axis once, the y-axis once. What is this one? A parabola, because it crosses the x-axis twice and the y-axis once. Agreed? Whew. All right. So I'm going to suggest to you that we ought to make a table. You guys remember back in those days? What is it? What grade would that be? Where you had to make a table and plot points? Was it 4th grade? I don't remember. Let's say 4th grade. Right? You're given an equation and you're like, okay, let me plug x's in there and find y's. Okay? So let's go ahead and do that. Oops. Let's actually do this. You can now. All right, so the next one is a parabola. So that means there's a curve to it, which means that I need at least 3 points. Right? With 2 points, I don't know how it curves. So I need a third point to guide me under the curve. Okay? That's number one. So the next question is, what x value should I use? I should use 0, 1, 2. Okay? 0, 1, 2. Okay? If I plug in 0, what am I going to get? One, 2. Wait. All right. Maybe he's just answering as if he was still in 4th grade. That's all. Because we were just saying we got to go back to 4th grade to make the table. But please keep your brain here. All right. So at 0, is that a closed circle or open circle? How do I tell if it's open circle or closed circle?
Because it has the thing underneath.
Mm-hmm.
So why aren't they all closed?
Look at it. With the red, -3, is there an equal sign underneath?
No. So it's open.
Correct. That's why this is open. Look at -3 in the blue. Is that closed or open?
Closed.
At 0, is it open or closed?
Closed.
At 0?
Oh, it's open.
Purple. Is it at 0, is it open or closed? And since it's going to go to positive infinity, that's why here I want to put an arrow.
So what do you do about the 0? You open?
That is just to guide me how to curve.
So it's not like these.
Correct. Right? I just need to know how to curve everything. All right. Let's graph this now. How am I going to get to -9? Hopefully this works. Fingers crossed. So let's plot these. -3, -7. And you said open circle, yes? And then -4, -9. Arrow. Everybody see the arrow? Does that make sense? Ask your questions. I'm piecing together 3 different functions here. Blue. -3, 3, closed circle. -3, 3, closed circle. Zero, 0, open circle. Zero, -1, closed circle. One, 0. 2, 3. Arrow. There's my graph. Does it pass the vertical line test? It doesn't? Does it pass the vertical line test? Is there a vertical line where it would cross this graph more than once? No. Because even here, this is not included. That is. Here, this is included, this is not included. So this actually passes the vertical line test. So again, I got to piece them together so that I still have a function here. Okay? Any questions here so far? No questions? No questions at all. So this is what I'm expecting on the lab work. Do we know where to pick the x values?
Minus the middle, like x equal.
Negative x?
No, like in the middle. If x is greater, less than -3.
Yeah.
So I think I would
Well, what's less than -3?
be -4. I'm thinking like I go the opposite direction versus, oh, let's do -4. I'd go like down to like -2. I don't know why.
Well, you mean you go up to -2.
Yeah.
But -2 is not less than -3.
It's just a little.
Understood. And if you think about money, what's less than $3 in debt? Someone that's $4 in debt. Someone that's $2 in debt is actually richer than you.
How is -4? Would you rather have less than? Would you rather have -$4 in your bank account or -$2 in your bank account? -2. It's cheaper. Pay off. Am I wrong?
That's why the -4 is less than.
The bigger the number with a negative, the more you want, the less it is.
So when I want less than -3, that means I want to be I want to be more in debt.
Okay.
I want to be poorer.
I want to be less than that.
I want to be poorer.
Okay. I want to rack up the credit.
Yeah. More poorer.
Got it.
That'd be less than. Greater than would be more richer. So far, so good? No questions. You guys ready for the difficult part? You guys ready for the difficult part? Yes, there is a harder part. So let's say I'm not given the graph at all. I'm just giving these three piecewise functions. And I ask for f of 2. I just want one answer. I can't plug it into all three. Because if I plug into all three, that means I don't have a function. Say that again. Whichever one is true. What does he mean? Wait, let me ask you guys this. If I was to translate this, right? Someone said to you, "Hey, what the heck does it mean by f of 2? What is it asking for?" How would you translate it for someone? And you're looking for y. So what is the y value when the x value is 2? But do you agree with that? Okay. Everybody understand that? What is the y value when the x value is 2? Okay. Where does the x value equal to 2 land? In the red, blue, or purple? Oh. Do you agree?
Yeah, because it's greater than 0.
So I wouldn't plug into all three, would I? I would plug into the one in purple. If I plug 2 into purple, what do I get? Agree? How about if I said f of -1? blue. What would you get? Negative, -1 is positive 1.
You're looking at the third equation. Sorry.
Blue. That's why I use blue ink right here. How about f of -3? Red? Blue? Burr? Red? So you, roux. Bread. Correct. The -3 is in blue because the blue includes the -3. The red does not include -3. Even though we use -3, that's why we had to use an open circle because it doesn't include it.
So do we have to include it, or can we just skip over it? Like,
Where are you going to put the open? Where are you going to put the open circle?
where it starts at. That's why we need it.
Right?
Yeah.
You can't just start at 4 because now there's an empty space right there. Make sense? That's why I use. So if you notice in my table here, I used all the critical points. So if you look at the critical points, is this right here and this right here, right? So you see it right here, right here, right here, right here. So the critical points have to be there. You want them there.
So what do we do about the third one? So can we do f of 1? Yeah. You did 5.
Well, so you can do f of 2 as well. That was the third one. Now, if I said f of -5, right? If I ask for f of -5, then yeah, that would be the first one. Now give me, is that right? If I said f of 0, which one would that be? Purple? But check this out, guys. Look at this.
So you're saying that we should do this rather than make it April 4th grade?
So, if you're asked to graph, table from 4th grade. Mine of today, table of 4th grade. If it's asking this, then you should identify where the x is laying. Then you know which equation to use. Is that fair? Questions? I know. About time, huh?
I was expecting you to fix it in the video and then you just ended the video.
You're like, ah.
That's the point.
I think it was like me going, making the realization that it's totally wrong,
Yeah.
and going,
I
yeah,
definitely took a little off.
I had it a lot off, because I came up with these equations that I think it was going to work, and it didn't work.
So you just kept the video up.
Yep, from 2 years ago.
If you watch the end of the video, you'll hear, like the last 3 minutes, you'll hear it. It's hilarious.
So let's talk about combination of functions. So combination of functions is more like operation with functions. So yes, f of x, g of x, and those such things. So if I see f plus g of x, that just means f of x minus g of x. I'm sorry, plus g of x. Sorry. That is called the sum. And that would be called the difference, hence subtracting. And then you got the product and you got the quotient. So that's combination. That's adding, subtracting, multiplying, dividing. Which is very different from the composite. So notice that the combination were operations, right? Adding, subtracting, multiplying, dividing. Composite is not any of that. It's not addition. It's not multiplication. It's not subtraction. It's not division. Composite, the way I look at it, is like the human centipede. Yes? So notice that the dot here is an open circle. And the problem is going to be on your homework assignments and the lab work and the exam, you're going to be like, the dot is so small that you're not sure if it's filled in or not. So you're like, is that open circle? Is that composite or is it a combination? If you look at the direction, it's going to tell you. Do the composite of. Then you know that is an open circle. All right, so the direction is going to tell you if it's a composite or not. Okay? So a composite is like the human centipede. Huh? That is gross. So what's a human centipede? The human centipede was, the thought behind it was you feed the head, and the result coming out of the head feeds the next link of the centipede, right? The composite is exactly that. So it's saying, I want you to do g of x first. Whatever the result that comes out, feed it into f of x. Okay? So do g of x first, then feed it into f of x. Does that make sense? So it's a two-step process. I eat, I result, he eats or she eats. Okay? But that's what a composite is. It's totally a human centipede. Tell me it's not. Should I show the movie? Oh, okay. I was like, I don't know how to show this example of a human centipede. I'm sorry. I'm stuck. Sorry. All right. So let's say, for example, I give you two functions. So let's say f of x is x squared plus 2. And g of x is x minus 1. So, no, I'm actually going to do one of the combinations and one composite, okay? I want to do both things. So I'm going to do both things. So let's say I'm going to do, you guys want to do multiplication, addition? You want to do multiplication? Okay. So let's say, for example, I'm given f times g of x. Well, that means I'm going to take f of x times g of x. So when you look at this, do you know what f of x is? Yes. Do I know what g of x is? Yes. So that means I would take the x squared plus 2 and multiply by x minus 1. So that means I got to double distribute, right? Does that make sense? So with addition, subtraction, multiplication, division, this is what it's talking about. That's all it's talking about. Nothing else. Yep. So what's a composite? Now, I'm sorry, before I do a composite, you might see this. So if it's gonna tell you to do f times g of x, that means my answer is gonna have x in it. If the x has a number, that means my result will be a number. So if that is the case, this is telling me that I got to find f of 3, find g of 3, and multiply them together. Make sense?
So when we're doing a combination, do we have the option to put whatever we want, or will the question state like, hey, find the quotient of this combination, or find this product of the combination?
It will probably say do the combination. But based on what it's given here to you. Because those are going to give you different answers, right? The addition ones are going to be pretty obvious. You're going to see the addition sign, right? You're going to see the addition sign. You're going to see the subtraction sign. You're going to see the division sign. It's usually these ones, like, you're going to be confused on seeing this versus seeing this on a piece of paper. On the combination, addition, subtraction, and division are pretty obvious what they are. Is it multiplication or is it composite? That's what you're going to be confused about. So if it says combination, then it must mean the multiplication. If it says composite, it must mean composite. Okay? So over here, again, I'm still using these two functions here. Okay? So if it's asking for this, that means I got f of 3. And what's going to be f of 3? How do I find f of 3? How do I find f of 3? How do you find f of 3? Plug 3 into the f function. This is the f function, right? If I'm plugging 3 in here, that means I'm plugging 3 in here, right? This is a g function, right? So I'm plugging 3 in here, that means I'm plugging 3 in here. Does that make sense? Now, if this work is already done, yes, I could have just plugged 3 in here as well. I could have done that. However, here's the thing. Sometimes it's just going to ask for this. Are you going to mess with doing this whole thing and then plugging 3 in there? No. Does that make sense? Now, if they did this as part 1 and this as part 2, yeah, it would make sense for me to just throw the 3 in there. Now, if I throw the 3 in here, Should I get 22? Absolutely. I'll still get the same answer. Does that make sense? Okay? Now let's talk about composite. So this means f of g of x. Do I know what f of x is? I mean, what g of x is? Yeah, I know exactly what this is, right? So how do I find f of x minus 1? You would plug x minus 1 into the f function. Here's the f function. Oh, here, let me do this. Let me help you guys out. Yeah, let me help you guys out. Let me help you guys out. There you go. Is that better? Okay. So you're telling me that wherever x is, I want to replace it with x minus 1. Is that what you're saying? Like this? Is that right? Yay. Gesundheit. Are we okay there? Yes? Hercules.
So you pulled x squared minus 2x plus 1 plus 2 from upstairs.
From doing this right here. It's like you said, foiling this or double distributing this gets this, and then plus 2. So again, because the inside the parentheses was x, I'm going to get it looking like x, right? I better do this in case if you guys get lost again. But what if I said this? F composite g of 3. So that means I have to find g of 3 first. And g of 3 is equal to so
Put 2 for x for the blue equation.
does that make sense? Questions?
So when we're doing MyLab math, what is a good way to put in what you know?
Well, remember the combination is based on this, right? So essentially, what do you see? What does it mean, right? So what are some of the things that we already messed up on as we were trying to answer questions?
What was f of
When we said, what was f of 3? Right? when we said what was f of 3, you're like, or x or f of, or no, I'm sorry, yeah, f of x minus 1. Like solve for x. What? Right?
So like solve for x minus.
So, no, you would just say f of x minus 1 would be what? It would be plugging in x minus 1 in the f function. Right? Because that's what you did here, right? So when we did this, we had to plug in x minus 1 into the f function. So that's what you need to explain of I'm putting what's inside the parentheses into the given function that's asking for, right? That's the real whole purpose of a function notation, is to know which function to use as we go, right? Does that make sense?
Yeah.
So do we see the difference between combination and composite? And why composite will be more like a human centipede, right?
I mean, I don't really think about it yet.
But we did, though. I mean, look at this. We had to feed G, the 3. G is working through it, through the system, regurgitate it, and then it goes into F.
And then you do F.
And then F comes out, regurgitates it,
G, F,
and now it's 6.
G, F.
6. Right? Make sense? 6. Perfect example there. All right, so let's talk about domains. Yeah, well, this was part of the video, but it was not as, I think this would be better.
Is this like 8th grade stuff?
No, because I already talked about domains, right? Domains, all possible x values. But I said to you guys, we need to assume that domains are going to be from to, aka, do you guys remember what I said? Assume that all domains are negative infinity to positive infinity, also known as all reals.
It's not true for the word.
Do you guys remember this? Except for when?
There's like weird graphing.
When there's weird graphing.
So there's numbers included sometimes.
The weird graphing that she is talking about is about fractions. Or a square root, correct. So let me ask you this. If I had x over x plus 1, so what is that about fractions? What did we say? So we said that the denominator cannot equal to 0, right? So look at the denominator. We're going to take that denominator and say that that cannot equal to 0. Let's solve for x. X cannot be negative 1. Everybody agree? Okay. X cannot equal to negative 1. Okay. So if that's the case, what is my domain then? So some of you guys might need to do this. You might have to draw this line, put this negative 1 down. Since it cannot equal to negative 1, it'll be open circle. And then draw your arrows to both ends, because everything else can be used. Right? I can use negative 2, 0. I can use anything else except for negative 1. That's the only one I can't use. So my domain is going to be negative infinity to negative 1, union with negative 1 to infinity. Because the only number I can't use is negative 1. I can use anything else. Because there's no other number that would make that denominator 0. Except when x equals negative 1. Make sense? And drawing this makes this a lot easier to write.
You gotta write it for both sides this time.
Correct. And a second possibility is a square root. So let's say x plus 6. So what did we say about square roots? So we said the radicand had to be greater than or equal to 0, right? So look at this. I'm going to take the radicand and say it's greater than or equal to 0. So let's graph it. So the x is going to be greater or equal to negative 6. Mm-hmm. So if I put negative 6 here, is it going to be an open circle or a closed circle? Awesome. Pointing to the left or right? Anything pointing to the left? No. So that means my domain here is what? Does that make sense? Now here's the one I want you to think about. What happens to that? So I'm not worried about rationalizing the denominator. I'm more worried about the domain. Because no matter what I do, I still got to worry about the domain before. Because remember, whenever we did rational stuff, we dealt with restrictions before we started to simplify. So we can't simplify yet, right? So if we follow what was said up here, right? I could try to follow this, but can the denominator equal to 0? So everybody pay attention. Look at this. That means this right here got to be deleted. Does that make sense? Because it can't equal to 0. So we got to take that away. So notice something, guys. Bless you. It almost looked the same, but what's different, guys? This goes away. Yeah. See how it's different?